Hello, this is a C2 video, part 1 actually of 2, you'll be delighted to hear. Now this one, it's more about differentiation. It's just a little extension from what we did in C1. Yeah. As I said, this is the first part. There is another part about optimization, but I'll try and break it up a little bit so it's not too much. Okay, so let's start with the basic sort of stuff. So we're going to be using one main equation, one example. I'm going to keep it fairly short. I will do a few more, but this is the main one we'll be using today to start with. So there's an equation. It says y equals x cubed take 3x squared plus 6. Now to differentiate that, what you basically do is for each x term, so x to the power of 3, you times that by the coefficient of that x, so the number in front. It's a very fancy way of saying times it by this number here. So that number by this number and reduce that power by 1. So if we do that, this becomes dy dx. So 3 times 1, it's essentially 1, because 1 times anything is itself. We reduce the power by 1, so that 3 times 1 is 3, 3 take away 1 is 2, so 3x squared. What we've got here, 3 times 2, which is 6, reduce the power by 1, so that's the same as saying 6x. And obviously there's x to the power 0 here, you can imagine, because anything to the power 0 is 1, so we can assume that 6 is 6x to the 0, or just 6. So therefore, we times 0 by 6, so basically there's no x there, so all you need to understand. So my ears starting to go. Right. So that's a differentiated equation. That's something you would have seen in C1, or if you're very advanced at high school, you would have done something like that. Okay, so how do we sort of extend this into sort of C2 maths? Well, I think the first thing we need to talk about is well, I think we'll do the graph actually first before we get into any real sort of questions. So obviously we know the y-intercept is going to be 6, and it's a positive x cubed, so it is going to go something like that, but it's going to have 3 intercepts. Is it? 2 actually. That's x, y. It's going to do something like this. So that's actually going to touch it there, that's 2. And that's 6. And obviously if we factorise that, we would get whatever you would have there. So it just touches there and goes through at that point. So, I mean, we could factorise that, but this isn't what this topic is about. It's more differentiating rather than trying to interpret cubic graphs, which is more a C1 topic really. So, how can we work out, what can we use this for to work out the vertexes in this equation here? So, well, if we can work out the coordinates of the turning points. Now if it's an x squared, it's a vertex, so it's going to something, I'm actually going to draw that, it'll look like a U shape, it'll be a parabola, so it'll have one vertex, but as this is a cubed, it goes down to a quadratic, so therefore, there's 2 values of x there, we can already just working that out, because when you factorise a quadratic, you get 2 values for x, so we've got x there and x there. So they're the 2 turning points. Sorry. The turning point is up there, and turning point is at 2. Yeah, that's right. So how can we work this out? Okay, so we've got 3x squared here. So when this equals 0, at any vertex, any vertex on any curve, as we basically draw a straight line, horizontal line to represent that, which you're going to have a gradient of 0. So we put that, that's a gradient function. So if the gradient function equals 0, the gradient is 0. So we put 3x squared, take 6, x equals 0. We can factorise this. The simple, because there's no like plus 3 at the end, we can essentially just take 3x out as a common factor. 3x, x, take 2. So that means x is going to be 0 for the 3, or x is going to be 2 in the brackets. So there are two values of x, and they're the two turning point coordinates for x. So simply all we do to get y is we have this equation up here, substitute it in, so y equals, I'm going to do the 0 first, 0 cubed, which is just 0, plus 3 times 0 squared, which is 0, plus 6, so therefore y equals 6. And we put 2 into the equation, y equals 2 cubed, plus 3 2 squared, plus 6, therefore y is equal to 2. Hopefully this seems okay so far. So there are the two coordinates, if we jumble these all up, is we have 0, 6, which is this one up here, so that is 0, 6, and this down here, we have our x coordinate of 2 and our y coordinate of 2. 2, 2. Yeah, so it doesn't actually touch it there, we've drawn it correct. So that's the coordinates. Now, the next thing we need to work out is the nature. So obviously we can see by the graph that at 6 it's going down, so it's at a maximum, whereas the other coordinate, 2, 2, is at a minimum, it's starting to go up. So how can we determine whether it's going up or down, apart from looking at the graph? Well, if we differentiate this again, so d squared y over dx squared, basically all we're doing is differentiating this equation, so 2 times 3 is 6, x, reduce the power by 1, take 6 times 1 is 6, reduce power, we just take 6. So that's our second differential equation. Now that doesn't tell us if it's positive or negative, it helps us to guide it at these 2 points. If it was a quadratic, what we'd have here when we differentiate it twice was just a number, either positive or negative. So we can come up with a rule for this. So I'll explain that rule when I've explained the, if we just bang these x's in. So we've got x is 0 for the top one, so if we do that, do this one, 6 times 0, take 6, equals negative 6. So that's going to help us out in a minute. So that's for that one. 6, if we put 2 in, so 6 times 2, take 6. 6 times 2 is 12, take 6 is 6. So it's going to get positive 6. So what can we work out from this? Now I trust that you'll understand me and agree with me when I say, well, you can try it on any curve you want, it's in your maths book, and you know. So if we've got 6 at the top here, that's going down, and it's got an x coordinate of 0, and we look here for that one, it says negative 6. Now the fact that they say both 6 is just a coincidence. I'm going off the facts whether it's positive or negative. So this 2, when it's going up and it's at a minimum, we've got a positive value of 6. So we can say when it's going down, it's negative, and when it's going up, it's starting to go up, then it's positive. So if it's starting to go up, it's going to be starting at a lower point if it's continually increasing. So if it's positive, is going to be a minimum, because a positive means it's increasing the gradient. So yeah, so positive equals minimum, and negative equals maximum, as the gradient is going to be decreasing. And maximum. Hopefully you've understood why we've got each of them values from there. Just to make sure you can actually see that there, and it's not just a load of gobbledygook for you. Yeah. Okay, so hopefully you're starting to get that. Right. So it says the next part. Sorry, I get my head out of the way. Find the values for which x for the function what we've got at the top, y equals x cubed, take 3x squared, etc., is increasing. So I know we said it's increasing after 2, and it's increasing before 6. So if we split it off, I'll get a different colour. It's getting crazy again. I'll split it off. So put a line here, put a line here. So when it's blue, I'm going to say it's increasing the gradient. So yeah, should be going after here, as it's always going to be going back up. It's never going to be coming back down again, as there is no more intercepts that we can mathematically prove there. So unless there's some change in the formula, which we can't let it, they're going to be the only intercepts for this curve. So we go back to our equation here. So we've got x is equal to 0, which is this, or x is equal to 2, which is this. So I'll just put x equals 0, x equals 2. So what we can say is after x is 2, the gradient is increasing. However, before x is 0, the gradient is also increasing. So this is our gradient function here. So if we've got x is 0, obviously this is what we're going to be using the bottom on. That's just the gradient function, but we know it equals 0 at this point. So if we put that in, so I'll rewrite this equation actually. 3x x take 2 is greater than 0, and that is because it's greater than 0 because this is the gradient function, and it's got to be larger than 0 if it's increasing. So it can't be getting smaller, of course. So if we put our now what we do here, if we didn't have, I'm doing this assuming we didn't have this graph. If we had this graph, we could just simply say x is less than 0, x is greater than 2. If you don't have the graph, you just simply bung in the numbers to this equation here, and find if x is 0, if it's less than 0, pick a number that's less than 0, shove it into that equation, and see if it's greater than 0, put a number that's greater than 0 into that equation, and you will get a value. And if it's greater than 0, you know that's the value of x. If x is bigger or larger than 0, as it's an equation, or if x is larger or smaller, then if x is larger or smaller than 2, it gives you a value that's greater than 0, you know that's the one to go for. So in essence, if we look at this diagram, we know that x is going to be less than 0, and x is going to be larger than 2. So there are your two values there. So you could put that into if it says find the range of values, then that's your range there. That's as I said, it's quite a quick introduction into the topic, and hope you've enjoyed it. I'll see you in the next video.